Section 8.5, adding and subtracting rational expressions. The objective is to add and subtract rational expressions. To add or subtract rational expressions, find a common denominator, or the LCM, of the denominators. To find that LCM, factor completely and find the product of the prime factors, each raised to the greatest power that it occurs in any of the expressions. Problem 1. What's the least common multiple of 12x squared y times the quantity x squared plus 2x plus 1 and 18xy cubed times the quantity x squared plus 5x plus 4? So the first thing I'm going to do is factor those parentheses. The first one becomes x plus 1 times x plus 1. The second one becomes factors of 4 that add up to 5, x plus 4, x plus 1. So 12 x squared y times x plus 1 squared. Okay, and we're also going to do 18 xy to the third times x plus 1 times x plus 4. Now, what I'm going to do first is look at the numbers. I'm going to do a factor tree for each one. For 12, it's 4 times 3, and 4 becomes 2 times 2. So for 12, it looks like it's 2 squared times 3, x squared y times x plus 1 squared. For 18, something similar. We get 2 times 9, and 9 is 3 times 3. So for 18, we are looking at 2 times 3 squared times xy cubed, x plus 1, x plus 4. So we're going to look at each of these numbers and variables separately. So our end result's going to look more like this. First, we're going to look at the 2's. Notice the highest one is 2 to the 2. The lower one is 2. Above, we read that we have to choose the highest one, the highest factor, and this one would be 2 to the 2. When we look at the 3, we have a 3 to the 1 or a 3 to the 2. We're going to choose the highest one. It doesn't matter that they come from different factors. Then we go on to each one after that. So x is raised to the 2, x is raised to the 1. We're going to take the higher one. Y to the first, y to the third, we're going to take the higher one. We have x plus 1 to the 2, x plus 1 to the 1, we're going to choose the higher one. And then we have one factor of x plus 4. Okay, and then we simplify it to make it look just a little bit nicer. So our final answer would be 4 times 9, which is 36, x squared y to the 3, x plus 1 squared, x plus 4. So you can pause the video now and work on the got it question number 1. Check your answers when you're done. This should be what is the LCM of the expressions. In the first one, we're going to do 2x plus 4 and x squared minus x minus 6. So looking at 2x plus 4, we can factor a 2 out and we get x plus 2. Looking at x squared minus x minus 6, we get x minus 3, x plus 2. So my least common multiple is going to be one of each thing. I have a number 2. I have an x plus 2 in the first one, an x plus 2 in the second one. Neither one are to higher exponent, so I just choose the 1. I also see an x minus 3. We need one of those. So 2 times the quantity x plus 2 times x minus 3. In the next one, we have 3 sets of things. X squared plus 3x minus 4 gives us factors of -4 that add up to 3. X plus 4, x minus 1. The next one becomes x squared plus 2x minus 8. We have factors of -8 that add up to 2. And the last one, x squared minus 4x plus 4, gives us x minus 2, x minus 2. That would become x minus 2 squared. So we have everything written. My least common multiple is going to be, if we scan through them, we have an x plus 4, an x plus 4, and then nothing. So I'm going to choose one of those. We have an x minus 1 only in one of the terms. We need one of those. We already did x plus 4, so I'm moving on to the x plus 2, or x minus 2. We have x minus 2 once in the second term, but twice in the third term. We're going to choose the higher of the two. And that should be it. You don't have to multiply it back through. Just leave the factors. If you're wondering which factor goes first, it doesn't matter as long as you have them all and you have them to the right exponents. The least common multiple of the denominators is also called the least common denominator, which is least common denominator of the rational expressions. So LCM and LCD are very close to the same thing. Now, the next few problems I had to write out because my Word program was not responding today, so we're just going to kind of wing it for the rest of the time. I'll try to do different colors. What is the sum of the two rational expressions in simplest form? So the first thing I notice is the denominator of the second term is not factored, so we need to factor anything that we can. Look for numbers to take out, x's to take out, and then to factor a trinomial. Now we need to put them together. What I'm looking at is just the denominators only, so I'm looking at these things. We need to find the least common denominator here. So my least common denominator is going to look like this. I have an x minus 1 over here. I have an x minus 1 over there. I need one of those. Okay, so sorry about that. We have an x minus 1, and we also see an x minus 2. Now, what the goal is try to make every term have that same denominator. You can't just force it into being 1 without multiplying times what you're missing. So in order to make our first term look like the second one, we need a factor of x minus 2. And you have to multiply the numerator and the denominator times that factor. The second one is already okay. So now we simplify. X times x. Sorry about that. My screen keeps moving here. And then we see a plus in the middle and a 2x minus 1. So now we multiply out the numerator. We get x squared minus 2x plus 2x minus 1. Denominator stays the same. Now I see that the 2x's cancel. So we get x squared minus 1 and the denominator stays the same. And now I notice that the numerator is a difference of 2 squares. That we can factor down even further into x minus 1, x plus 1. So my x minus 1's cancel, and I'm left with x plus 1 over x minus 2. And we also, in the directions, it says state any restrictions on the variables. So we look at the beginning, and we had an x minus 1 in the denominator, so we cannot have 1. We had an x minus 2 in the denominator, so we cannot have 2 either. And that should cover it. You can also put those together as x cannot equal 1, 2 if you'd like to. Remember that goes with anything that is canceled out as well. If you'd like to pause and try got it question number 2, you can check your answers when you're done. What is the sum in simplest form? State any restrictions. So what I noticed first is that you can factor an x out. And then we're going to get a least common denominator. I see an x in there, and I see one factor of x minus 1. Now I need to make each term look like that. The second one is already okay. The first one I do need to multiply times x. Don't forget to distribute on the top. So it looks like x times x plus 1. So in the first term we have x times x plus 1. The second term we have adding a negative 2, which is basically like a subtracting 2. And then we're just going to simplify to see what happens. Do not start canceling things out because you will not get the right answer. Simplify the numerator, then see what happens. So it looks like x squared plus x minus 2, and then x times x minus 1. The numerator is a trinomial, so I'm going to try to factor that. X plus 2, x minus 1 over x, x minus 1. The x minus 1s are now gone, and we have x plus 2 over x. That's as far as we can go. Remember that you can't break up a sum or difference. Oops, I forgot to get my restrictions. X cannot equal 0 or 1. Here's part B. The first term has a difference of 2 squares, which means the second term is missing that factor of x minus 2. So we've got x plus x minus 2. I'm going to put the like terms together. 2x minus 2. Which looks like you can factor a 2 out of the numerator. The book will probably turn this back into x squared minus 4, but it doesn't really matter to me because when you have 3 or 4 of them, you're not going to multiply those all out anyway, so you can leave them if you want. Now my restrictions, I had a 2 and a negative 2, so we can't have those. And I think that's it. Okay, now we are going to add or subtract, which is subtracting next. What's the difference of the two rational expressions in simplest form? And then state any restrictions there too. So again, the first thing we're going to do is try to factor and simplify as much as we can. In the first one, we can take an x out. Excuse me. The second one, we can take a 2 out. And now we need a least common denominator. I see a 2 and an x, and then we have one factor of x minus 2 in each one. So that looks like we're good. If you compare this denominator with the one that we need, I'm looking at this one. Oops, it didn't change colors. Hold on. I'm looking at this one compared to this one. Notice how we are missing a 2. Now it looks the same. In the second one, we are missing the x when you compare this one to this one. So doing a little simplifying, we get 2x plus 4 minus x squared minus 2x. Remember that this negative carries through to both of those. It's like a negative x times x and a negative x times 2. So we're going to simplify a little bit. I'm going to put the negative x squared first. Then my 2x cancels with my negative 2x, so I get a plus 4. Denominator still looks the same. I think that's the difference of 2 squares, so I'm going to take out a negative 1, which changes the sign of both of those. So it looks like this, x minus 2, x plus 2, 2x, x minus 2. The x minus 2 is gone, and I think that's about all we can do. Now my restrictions, I cannot have a 0. I cannot have a 2. And I cannot have, oh, that must be it. I'm looking at this one for those restrictions. So if you want to pause and try got it number 3, you can go ahead. Difference, once again, we're going to factor first. X minus 2, x minus 1, because we need factors of 2 that add up to negative 3. If you compare the first one to the second one, we are missing a factor of x minus 1. Remember, you have to multiply the whole entire factor that was there before. So it kind of looks like this. So x plus 3 times x minus 1 would be FOIL, x squared minus x plus 3x minus 3. This negative carries through to both of them. So we get minus 6x plus 7. Now putting like terms together, we get x squared. We have a negative 1x, a positive 3x, and a negative 6x. So that would be a minus 4x. Wait. Yeah. And then plus 4. Everything else will stay the same. This is a trinomial, so I'm going to factor this one. X minus 2, x minus 2. Those are gone. So that leaves me with x minus 2 over x minus 1. And the restrictions would be 2 and 1. I'm kind of looking at this part right here for those restrictions. Here's part B. If we factor first, factors of 5 that add up to 6. A lot of times your least common denominator is going to be one of the two fractions. So we have an x plus 5 in both of them, so we're going to choose that. We're also going to choose the x plus 1. Looking at that, my first term is missing the x plus 1. Many people that don't write this in get these wrong. They assume they have it, but they don't. So we are looking at this. We're subtracting this whole term. So a little simplifying here. X squared plus x minus x, those will cancel. And then we have a minus 1. So we have a negative x and a negative 3. Those are gone. So we are left with x squared minus x minus 4 over x plus 5, x plus 1. Trinomial once again. X minus 4, x plus 1 over x plus 5, x plus 1. The x plus 1s are gone, and we are left with x minus 4 over x plus 5, and the restrictions are right here. We can't have negative 5, and oops, now it changed color. Cannot have negative 5, and we cannot have negative 1. Okay, I just noticed that I made a mistake, so I'm going to go back a little bit. Right here where I tried to factor, I was just looking at that and multiplying it, and it doesn't work. We actually get negative 3x in the middle. I'm going to leave it like it was, and then put my restrictions there instead. So I think we're done here. So x cannot equal negative 5 or negative 1. So there are no factors of negative 4 that add up to negative 1. Sorry about that. This is day 2. Rational expressions that have at least one fraction in the numerator or denominator or both. So these 3 things that are listed here are just different examples that you might run into. There's a couple different ways you can do these. I feel like simplifying the numerator and then simplifying the denominator second and then putting them together is easier. The book does show both of them, so please feel free to refer to that if you want to. So what we're going to do is we're going to simplify the numerator, simplify the denominator by doing what we just did, and then multiply by the reciprocal. So the denominator for the top will be xy. The first one is missing the y. The second one, to make it an xy, would be missing the x. So we get y plus x squared over xy. The denominator, you'd have a y for the least common denominator. The first one already has a y down there, so the second one you'd multiply by y over y. So it looks like 1 plus y. Now this is the same as this. And remember, when we divide by a fraction, we multiply by the reciprocal. So what we're going to do is we're going to flip that second one over. We're also going to remember that when you flip that over, it's got one more restriction than it had before, because right now y is in the denominator, but when we flip it, 1 plus y will be there as well. So we might have a few more restrictions on this one, if they make you do restrictions. Otherwise, you don't have to. So it looks like this: y plus x squared over xy times y over 1 plus y. Now remember that anything on the top that's a sum or difference cannot be reduced. If you put the letters that are alone in front, it kind of helps you to see sometimes if you can simplify more or not. And on this one, we can simplify those y's out. So it looks like this: x squared plus y. You could leave it y plus x squared over 1 plus y. For these, again, if it's a sum or difference, you want to leave it just like it is. Anything that's a product sitting out front, you can simplify those out. Here comes the got it questions for number 4. There's 2 more. You can pause and try them if you want to. So top part is okay like it is. The bottom part, my denominator is going to look like an x and a y. I need one of both of those. So this one, to have an xy, I multiply by y. The second one, I multiply by x. So next step is to divide. So this is an x over 1 divided by y plus 1 over xy. So remember, to divide by a fraction, we multiply by the reciprocal, and then it looks like this. So we get x squared y over y plus 1. Okay, I found another mistake on this one. I've been interrupted too many times. When I am multiplying this right here, it should have been 1x on the top. So x over 1, and this one should have an x with it, and this should have an x with it, and so should this. So I fixed that one, and also let's do the restrictions on these so you know how to do that. I'm going to change this to purple now. Okay, so we can't have x equaling 0. We cannot have y equaling 0. And this one we run into a little something new. So the place that I got that from is right here. We can't have x and y being 0. But at the end, notice we have a sum. And if you go like this, y plus x equals 0, you cannot have y equaling the opposite of x either. So if you ever run into that where you have like a sort of sum or difference in the denominator, you do have to consider that, and what you do is just set it equal to 0 and solve for y. And that would be the part that you wouldn't be able to have. Let's try one more of those. This one's a little bit longer, a little bit harder. So we've got some fractions all over the place. None of them can be simplified, so I'm going to put the top parts together. We need an x plus 1. So this one right here is missing the x plus 1, top and bottom. The other one is missing the x. So this one looks like this: x minus 2, x plus 1, minus 2x. On the denominator, we need an x minus 1 and an x plus 1. So this one is missing the x plus 1. This one is missing the x minus 1. So it's 3 times x plus 1 minus 1 times x minus 1. Now we're going to do some simplifying here. X squared plus x minus 2x minus 2 minus 2x. So I foiled that, and then I copied the rest. We're going to do the same thing in the denominator. We get a 3x plus 3 minus 1x plus 1. Put a little like terms together. So we get x squared oh, my sign is wrong here. This should be a plus. There we go. X squared plus x minus 2. Denominator should be 2x plus 4. We have a trinomial in the top. We just need to figure out, do we have factors of -2 that add up to 1? And we do. X plus 2, x minus 1. Divided by 2 times x plus 2. Remember, we're going to multiply by the reciprocal, so we need to flip this one over. Ran out of room here, so let's see. I'm going to write a little bit smaller here. Okay, so we have an x plus 1 that will cancel. We have an x plus 2 that will cancel. So we get x minus 1 squared over 2x. Now we have our restrictions. X cannot equal 0, -1, or -2. And we have to consider both the numerator and the denominator. Right here, we have a 1 on this one, a -1 here. We also get a -2, so I need to add a 1 in there as well. So the numbers that we cannot have are 1, -1, 0, and -2.